Okay, I hope you had a chance to do some work yesterday. If not, it's never a big deal. We are just going to do the solutions for the similar triangle worksheet. Then I'm going to make another video where I told you I'd do some word problems, just a real short assignment today. Okay, so what are two criteria needed for triangles to be similar? Okay, so corresponding angles are equal, and the other one, sides are proportional. Okay, so state whether or not these ones are similar. Okay, and remember, similar is different than just kind of looking the same, okay? So when you first glance at this, you only see one angle that's the same. So we have to go back and we have to remember what we learned yesterday, which was the interior angle sum. All the angles inside of a triangle have to add up to 180. Okay, so let's do this one. 79 and 67 is 146. And if we took 180 and we subtracted 146, lo and behold, we get 34. When 34 is here, 67 is here, so no brainer. 79 is going to be up here, so it checks that box, right? Okay, and now they are similar. Why or why not? See A and B, corresponding angles. Okay, and now it says if so. Okay, we're not going to worry about this piece right here. We're just going to find the scale factor. Okay, so we are going to take scale over original, and for ease I'm going to say that that one's the scale and that one's the original. And if I do that, I get 48 over 32, and you're going to get 1 5/10 as your scale factor. Okay, let's move on. Let's try this one. We got 57 and 85, and over here we have 38 and 54. Okay, there's absolutely no way that that's going to be similar. There's no way we can get even two angles that are going to be congruent, let alone three. So we're going to say no here. Angles not congruent. Okay, let's move down here to this one. Okay, are they similar? Let's check it out. So we don't have angles here now, so remember we have to do side lengths, and that's okay. That works too. So it doesn't matter which one you start with, but let's talk about these, and I'm going to label these, and if it was real life, I would call them large, medium, and small. And over here I need to pick the large one, large, medium, and small. And so now I'm going to check the scale factor, and I'm going to make large to large, medium to medium, small to small. All three have to be exactly the same scale factor. Okay, so I'm going to do the math down here. 24 over 20. 24 divided by 20, you get 1.2. Now I'm going to do the medium. So the medium is 18 and 15. 18 divided by 15. Doesn't have to be neat, right? We're just trying to do some work here and do some proving. 1.2, 1 2/10, looking good. And then 12 over 10, and that's 1 2/10. Similar? Yes, indeedy. Okay. Proportional. Oh, I don't think I spelled that right. Proportional side lengths. Okay, what was the scale factor? Well, I guess if we were going from here to there, 1 2/10. Okay, here we go. Same thing. I'm going to start with my large, medium, small. And over here, this is my large. This is my medium. This is my small. Okay, so we're going to compare. Matching corresponding sides. I always put the bigger number on top, okay? But it should work the other way, and so let's prove it this time. I'm going to get out of my comfort zone. I'm going to go 48 matches up with 96. So we're going to have a scale factor that's considered a reduction now. And I'm going to get 5/10. So this is supposed to be half. Okay, let's try the other one. And I know it's messy here. I would have probably done this on paper. My medium sides are 28 to 56. Ooh, looking good. Okay, now let's do our small sides. 21 to 42, and I can see that 21 is half of 42 immediately. So there we go. 5/10, 5/10, 5/10. Okay. Are they similar? Yes. What's the scale factor? 5/10. Now, you might have a different answer here. You might have 2 because you said that this was the scale and this was the original. So you're working on an enlargement. So it's important that we understand that, and it's okay, right? Because I didn't say this is the scale or this is the original. I didn't make that clear. Okay. So as long as they're the same for all of them, you've done it correctly. Okay. Assume now that the following triangles are similar. Okay. So we can see that they have the congruency symbols for our angles, and we know that if these two are exactly the same, that this one by default has to be the same because they all have to add up to 180. Okay, so what we usually do is when we are given both the measurements, we make that the original, and this is the scale. So it's going to be an enlargement. So now we look for, okay, sides that are corresponding. So this one and this one, and scale factor is scale over original. So we would say 15/5, and our scale factor here would be 3, okay? And it says find the lengths of the missing side. So here's our missing side. It corresponds with this side. So we can simply go times 3, and we're going to get an answer of 9. Okay, so we're told that these are similar. Here's my original because it has both measurements. Here's my scale diagram. So how do we find scale factor? Scale over original, so 12 divided by 20. When you take 12 and divide it by 20, you get 6/10. So now I can take this measurement here and multiply it by 6/10. And if you have 15 and you multiply it by 6/10, you get 9. Okay. So there we go. They didn't really give us a measurement, but we could say that it was centimeters. Okay. Now, this is what we're going to get into shortly. So this is sort of our introduction to word problems, and I hope you guys did okay. It says the triangles are similar, okay? So here we have the original. We have measurements for both sides. We know that these sides are corresponding. This is going to be my scale. So it is an enlargement. So I'm going to take these corresponding sides, and I'm going to say 2/10 matches up with 8 when 1 meter matches up with this. So this is what I'm going to do this time. I'm going to set it up as a proportion, and then we're going to go back and we're going to do it as a scale factor. I just want to show you how this works. We divide both sides by 2/10, and if you take 8 and divide it by 2/10, you get 40. So that's 40 meters high. Okay, the other way is we can take this, we can go scale over original, and we can find our scale factor, and our scale factor is 2/10, and then we just, now we have to multiply